Thank you for having me here. Yes, okay, the recording has started. You can hear me, right? So, okay, please let me know if there are any issues on the way. So it's really a pleasure to be here, and I really appreciate this really great initiative to have a series of workshops on advanced methods that can be helpful for social scientists and people from other fields as well. So the talk today is titled Computational Text Analysis for Social Sciences, and we'll try to outline some of the opportunities and challenges of using these methods. And I will be focusing indeed on social scientific applications, being that I come from a sociology background, but I hope it can be useful for other fields as well. So we'll try to keep it at a kind of general introductory level, but I've tried to introduce a lot of sources that should help interested people and gain an even deeper insight into these methods. So I think I wanted to go a little bit just through the agenda for today. And the idea is that I don't think I have to convince people here that we're seeing really a lot of new opportunities for using large data sources and text in particular in our research. And then I would like to go through some different tasks that text mining can help us with as researchers. Then I will reflect shortly on zero-shot learning models, given that we've now seen a kind of surge in interest in models such as GPT and tools such as ChatGPT. I think it's very relevant to reflect on that as well. And then we will go through some challenges and opportunities of using these methods in our scientific research, and more generally, the outlook that we're seeing as a society in terms of these tools. So you might notice, maybe some of the attendees might be aware of this paper. A lot of this talk is centered around the recent publication that I've had in social science research, which is titled also Text Mining for Social Science, the State and the Future of Computational Text Analysis in Sociology. In terms of developments in the field, November 2022 feels like ages ago, but I think it's still a useful reference. And you'll see many things that I will be talking about today are also discussed in the paper, and then often, of course, in more depth. But some of the newest developments are absent from there because they've happened since. Okay, so I think since we have everyone who has signed up for this talk, I don't have to convince you that much that we're seeing really a surge in the availability of large-scale textual data. Especially as social scientists, we're used to kind of going through a limited set of textual resources and reading through them. But now we have digitally available diverse textual corpora, including archival materials, so things that are being digitalized that were usually only kept in kind of basements of archives. We have official documents, we have news, and we have millions and millions of texts that each one of us generates every day on social media. And for social science researchers and researchers from other fields, this is really rich data that we somehow need to wrangle in order to extract useful information from it. And when I first started working on my dissertation, I had millions of texts coming from online platforms. As in the introduction we mentioned, I work with online platforms that are trading in illegal goods and cryptocurrencies and these environments. And I felt very overwhelmed, as this illustration is trying to show. It was made using generative AI image models. And I was just trying to understand how can we tackle all of these data in a productive way, and in a way that's consistent with the best practices and methodology of social sciences. So you might be already using, some of you might be using these methods, is that usually we as social scientists work with either quantitative content analysis, which includes systematic reading through text, oftentimes with the help of research assistants, for instance, and trying to identify whether text contains certain concepts that we're interested in. Some other researchers who are more in the qualitative schools tend to approach text more holistically. So we read a small sample of text, very in-depth. We're trying to connect them to other texts and through the context in which they were generated. However, if you ever had to deal with more than a few hundred texts, you'll realize that both of these methods are very time-consuming, and they can be costly if you need research assistance to try to tackle a larger number of texts. So in the light of that, we can now see that there's so many new, I call them shiny methods, because they seem very powerful. They seem to promise to kind of take away the time and the effort and the money it takes us to work with a lot of texts and kind of solve many of our problems for us. So this includes methods which are kind of coming from a family of machine learning methods, new software packages, and also tools such as, I think, most of us are familiar with by now, tools such as ChatGPT and similar chatbots that are trying to make these very complex language models and text analysis tools more accessible to ordinary people, and including also maybe researchers who might not be familiar with all the computer science developments. So in terms of navigating this world, what I would like to cover today is try to go over certain things that text mining can help us with and how we can then use it best as social scientists. So I wanted to, before we go into the particularities, maybe outline just the main principle the text analysis in general, and especially kind of large-scale quantitative text analysis can do for us. And the idea is the following. So we have certain raw text that contains a rich amount of information that we want to somehow represent as a numerical array. So kind of set of numbers that captures the meanings that are present in the text already. And then we want to map this numerical representation of textual data to certain predicted values that are matching outcomes that we don't know about, but we're trying to, kind of predict them in a similar way that we do when we use a regression model. So to give an example of this, for instance, we want to understand if a text is positive or negative. I think this is probably the simplest application, also called often sentiment analysis. So we have raw text. We somehow want to represent it as something that is interpretable in terms of numbers, and we want to map these numbers to whether the text was positive or negative, which is the predicted value of an unknown inherent nature of this text, which might be positive or negative. And then we can use these predicted values in our analysis. So some people do descriptive analysis with their textual insights. You can also use it in regression models, etc. So this is the main principle that we will be working with. So we are always trying to see how these numerical arrays can then help us get to the predicted values and how different tools can facilitate this process. When I talk about text representations, I also just wanted to kind of maybe make this also a bit more intuitive. Here's just an example of a few texts. These are just random sentences that we've chosen. And then we can choose to make our text interpretable for machines, because we want to use kind of machine-facilitated methods to tackle large amounts of data. And we can look at our text as, for instance, lists of words. Or we could also kind of recast them as matrices in which we could represent each individual text as a row, and then each word, this is only simplification, but all the words should be then columns, and we can use counts of words in each text as a way to easily represent text as vectors of numerical values of the words they contain. And then more recently, and I will not go into this in detail, I will touch on it a bit later in this presentation, but we can use also more advanced models that can help us translate words into vectors that are not only the counts of, texts into vectors and words into vectors. They're not simply the counts of their occurrences in text, but they're also kind of spatially related to each other in a multidimensional space. So if you think, for instance, about foxes in this kind of imaginary space of meanings, a fox would be probably closer to a wolf than they would be to an unrelated concept, such as maybe, I don't know, a house or something like that. So we can use more complex methods. I will talk about them more, which help us kind of have words as points in multidimensional spaces, which essentially just helps us capture meanings in numerical form and make use of them. And then finally, some methods also allow us to not only capture words in space, but also capture whole texts in space. And then texts which are more similar to each other will be closer in these spaces than otherwise. So essentially, the only thing that text representations do for us is help us capture, kind of raw text in a numerical form that we can then use with methods that I will discuss in just a bit. So you will see also, if you maybe go through that paper that I've linked to, is that this whole overview is organized around different tasks that we can use text mining for. You will see that many excellent overviews focus on different applications. For instance, you could think of social psychological research, sociology of culture, or sociology of markets, for instance. But what I wanted to do here is really look at different tasks and how certain methods are better suited for certain tasks than others. So we'll be looking at 4 main families of tasks, and this is not some kind of ultimate truth. This is the best I came up with based on my experience. If you have any suggestions, please do let me know. I'm always open to kind of extending this framework. But the idea is that we can use text mining to help us identify whether a certain concept we're looking for is present in text. Just following the previous example, we can think about positive attitude, whether someone sounds positive about something based on the text they've written. We can also use text mining to help us understand who is doing what in text. So if you think about, for instance, news articles, we can use automatic text analysis to help us extract kind of who are the actors, and what is it that they've done, and what is it that happened in text, but just on a larger scale. We can then also use text mining to extract, to understand what are the topics that are being discussed in different texts. And we can use them to try to understand how words relate to each other in different sources of text. And this is particularly important, as you will see later, if we try to kind of zoom out on how we construct meanings in societies and in different social groups. Yes, okay, and then now we will go through each one of these tasks, and I will just give kind of a brief overview of how these different methods work. So if we want to identify whether a certain concept is present in the text, this is, I think, one of the oldest kind of applications in computer-facilitated text analysis. And if you think about it, this is also very similar to the act of systematic coding that you might be familiar with if you worked with quantitative text analysis. So the idea is, using the simplest example of dictionary methods, that we have a list of words that are related to a certain concept that we're interested in. I will keep it simple, still looking at this example of text being positive or negative in their tone. So we can look at positive words. We can note that words such as glad or happy are denoting positive feelings. Negative words such as sad, unhappy, or dreadful are indicators of the negative attitude being present in the text. And then if we take a certain raw text, we can follow through the text. We can search for these words matching our dictionaries of positive and negative words. And then we can evaluate whether our text appears to be more positive or more negative based on the words it contains and based on the matches to our dictionary. So I think probably many people have used some of these resources. They're quite straightforward to use. They're technically also quite simple. But what you might see if you look at this short text from Charlotte Bronte's novel is that if we read through the text as humans, it is quite obvious that this is a rather negatively kind of loaded text. This person is talking about dreadful feelings, about being sad, being cold, feeling not very positive about it. But our dictionary actually found that there are 2 words from the positive list as well. So this kind of opens a window that despite these models being very simple, they can also kind of be too simple for some applications where we want to capture more nuance in the concepts that are present in the text. So what we can do then is we can, I'm running ahead of myself. I just wanted to say that I also wanted to list some of the applications and social sciences that have used these methods productively. So for instance, a really nice seminal paper from 2011 has looked at whether the sentiments people express, the kind of positivity and negativity people express in Twitter, reflects biological rhythms. For instance, people are in a better mood later in the afternoon than they are in the late nights or early mornings. And there are also specialized dictionaries. For instance, this famous dictionary that is centered around financial applications that can be used to extract different measures of revenues and earnings in different financial reports. So there's a lot of existing resources that people have developed for specific research questions, and they can be easily used to identify concepts in text. And there are also many available tools. So I will always list tools on these slides, but also we will make slides available later on, so you can go back to that. They're also in the appendix of this paper. So there are many kind of self-contained tools that you can use for dictionary analysis, which are fairly easy to use. And then both R and Python have very useful implementations, and these resources are often available open source, these dictionary lists that map words to concepts of interest. But then if we want to do this at a more kind of nuanced level, we can also make use of supervised machine learning classification algorithms. And the idea here is that we first analyze a sample of texts manually as we've been doing for years and years before we're using these automatic methods. So we'll have our human analysts denote whether these concepts we're looking for are present in a text or not. As you can see here on the right-hand side, that we will say that text 1 contains the concept of interest. For example, it's positive. Text 2 and 3 are not. And then we can use different machine learning algorithms to have them learn the patterns from human-coded data. They will essentially look at the words. They will look at the presence of a category in text and try to infer what is it in the textual data that kind of makes this link between the prediction and the features, the words. And then we can use them to reproduce these manual annotations. So we've used this in our work on online markets that trade in illegal goods, where we're looking at feedback that people leave and then trying to understand what are the different reasons for them doing so. But then people have also done things such as predict the stock market based on the sentiment that people express on message boards that are discussing the stock market. So these models in general are just helping us kind of evaluate a large number of texts for the presence of a certain concept of interest, and then we can use this in our regression analysis or also in just descriptive studies. There are methods of varying complexity that do this. So conventionally, you could do this with models such as simple as logistic regression, which you just have a category of interest, which is takes a value of 1 or 0, and then all the words in text are seen as kind of independent variables that you include in your regression. But there are also models that are more kind of catered towards classification problems more generally. So things such as naive Bayes or random forest have been algorithms that have been proven to be very helpful in text analysis. More recently, you might have also been aware of these developments. There's been a development of large language models, which I will also talk about in more detail just a bit later, which are these models that capture relationships between words in the multidimensional space, if you recall it from just a few minutes ago. And what you can do is that these models have been trained by large research teams or companies sometimes on very big amounts of data. And then you can use your own data that you've analyzed with your human coders to kind of train, or it's often called fine-tuning, kind of teach these models how to tackle your particular task at hand and then use them for this. And they will kind of automatically analyze the text for you, and they're very powerful in doing so. And once again, there are many, many tools available for this. R has a really good support for many models from these older families of supervised machine learning methods. For newer implementations, I've personally found that Python is the way to go. So it's much more accessible to get started with these large language models, for instance, in Python. But there are really a lot of available resources and a lot of kind of open source materials that help people kind of get going with these methods. So in the end, I think it's fairly accessible, but definitely a bit more challenging than using those dictionary methods that I've just discussed. Okay, and now we can move on to a different kind of task. So here, rather than just saying, okay, this text is positive or this text mentions stock prices, we can also use text analysis to understand who does what in text. And this is also equivalent to what is often called narrative analysis. And I think sociologists might have also worked with this a bit more. And the idea is that we have a text that describes a certain kind of chain of events. And then we can use the grammatical structure of sentences that describe what has happened to automatically extract who was the actor, what was the action, and kind of who was the object of this action. So this is often called SAO analysis because we're trying to identify so-called subject, action, object triplets. And just to give an example here, if we had a sentence that says something like Blake chases Riley, which is a very simple sentence, but just for illustration purposes, we could use the grammatical structure of the sentence to understand that Blake is our subject. This is the person who is doing something. The action that is happening now is that Blake is chasing someone, and the object is Riley, who is now being chased. So we can then use so-called semantic analysis, which looks at the relationships between words in sentences to kind of reconstruct what has been going on in these texts. And we can do this at a very large scale. So A really nice application that I definitely recommend reading is work by Francosi and colleagues, where they used a large data set of newspaper articles that have been digitalized. And then they tried to understand who were the victims and perpetrators of a series of lynching events in the United States, which was very insightful because you can really then analyze hundreds of texts and kind of get a very, very high level view of how things have been discussed in the media at the time. But people have also used this to understand, for instance, what are the rights and duties of different agents that sign labor union contracts as well. So you can really kind of zoom in on different actors, what they are doing, and if someone is suffering from other people's actions, we can identify this as well. There are, once again, a number of implementations. Some are more kind of technically advanced, some are less, and some of them are also kind of self-sufficient. So even if you don't prefer to use programming languages for this, they're really nice tools that can just do this very, very easily. This is a classical linguistic task. It can still be very demanding if the sentences are complex for machines. But the new developments have also really helped us with this. And this is one of the nicer, I think, applications that is very useful for narrative analysis. All right, so we can then also look at a large number of texts and try to understand what are the different topics that are present in the text and what are the things that these texts are discussing at large. And I think this is another set of methods that are kind of more familiar to a broader social scientific public because they've been very used, and especially in kind of maybe a decade ago, they were very, very big at a certain time. So I will be talking about topic models in general. This can be done with any family of unsupervised clustering methods, or if you've worked with principal component analysis, or if you worked with k-means clustering, the idea is very similar. So we have a set of data points. In this case, this is text. And what we're trying to do is we're trying to use a method to see if we can find some kind of latent underlying structure in these texts that is, as happens to be when you're working with textual data, organized into topics, into words that tend to occur together more frequently than they would by pure chance. So essentially then what we're trying to do is if we have a set of data points, a set of texts, we're trying to see if we can find some underlying topics that connect these texts. Now, additionally, a particular family of topic models, and in particular, the most famous and most widely used one, which is called LDA, latent Dirichlet analysis, tries to do two things at the same time. So first, we're looking at words, how they co-occur across different texts, and we're looking for words that tend to occur together in clusters. So I had this example, I think, with fox and wolves. So fox and wolves are more likely to be, occurring together, and then maybe stocks and stock market traders will also be occurring together in similar families of texts. So these models try to look at words that co-occur together, and then they're clustering these words into topics. Topics are just groups of words that statistically occur together. So this is what the model outputs for us. And then the model also tells us to what extent each text is made up of different topics. So in this sense, they're very useful because they allow us to not only identify what is being discussed in these texts, but to also see to what extent texts contain different kind of topics of discussion. So one very nice sociological application that I found intriguing is, for instance, these models have been used to understand how did first and second wave women's movement organizations discuss their political messages. So the first and the second waves of women movements had different goals. So we could look at this at a very large scale with the help of these topic models. But then also people have used these models to try to understand what features of writing of different CEOs of different companies correlate with their company's productivity. So there's really different things you can do, and you can be very creative with these models. Since they've been a staple in kind of social scientific text analysis for a while, there's also a range of very, very useful implementations that are also quite straightforward to use. More recent developments have also allowed us not only to look at different topics in text, but then also trace how these topics evolve over time, or also give the model a few words that we're particularly interested in. So if you're looking at text about animals, you can say, I'm really interested in foxes. And then the model will look at words that co-occur around this word and then help you kind of guide your research a bit more. These models have been used particularly in descriptive analysis because they give you this kind of high-level overview of what's going on in text. Okay, and then we can also move on to try to understand how words relate to each other. And I will go into this a little bit more now. So this is in general a family of methods that are both a type of methods that allow us to represent text. If we go back all the way to the beginning of my presentation, when I talk about these different ways in which we can represent text as numbers, but as such, they also allow us to infer how meanings are constructed and how words relate to each other in terms of kind of research questions. So essentially, I'll be here talking about then a family of models that allow us to capture, to make so-called distributed text representations. I will not go into the technical details, we don't have enough time today, but the idea is, here you see a visualization that should help with the intuition a bit. Let's say we have this three-dimensional space of potential meanings that word can take. And then we have these large models. So what we do is we feed a big amount of textual data to a certain model. These are usually neural networks, but I will not go into that in too much detail. But what we're doing is we're letting these models read and read and read through a lot of text. And what they're trying to do is they're trying to understand how words occur next to each other. So if we talk about foxes, they're more likely to be in forests, and they're more likely to be discussed in the context of maybe approaching farms or living in the woods or encountering other wild animals. And over time, as these models read through different large amounts of data, they will start capturing the relationships between foxes and all the other words that they usually occur in the same kind of environment with. And they will start positioning words as vectors in these, let's say here, this is three-dimensional space in this picture that you see, so that essentially when it's all said and done, when the model is done running on all the data we had to feed it, that we will see that foxes tend to be in space very close to wolves and other wild animals, but then they tend to be very far from Wall Street bankers, who then on the other side are all kind of in a similar space to each other. So what this allows us to do as sociologists is also look at how the written sources we produce as societies or as individuals then reflect these relationships between concepts and meanings in themselves. So these are both a tool that can then be used with other methods, but as such, these representations also tell us a lot about how we structure meanings and how we talk about things and how we say things. So to maybe make this a bit more concrete, I've once again kind of talked without going through the slides, my apologies, but essentially, as I said, maybe I will just build up on this a little bit, is say that we are capturing the context in which each of the words appears, but then also what more advanced methods can do is that they can capture the fact that the same word can have multiple meanings at once. So this can be as simple as, for instance, having a bark of a tree, which is one meaning of the word bark, but we can also have a bark of a dog. So when a dog is barking, we want to differentiate between that bark and bark as a part of a tree. So we have models that are also able to capture the fact that we have two words that sound essentially the same, but might be very kind of having different positions in these spaces of meanings. And as I said, these models are usually trained on large textual corpora, and this is done often by research teams who have access to a lot of data. The simpler models, which capture only the word context, you might have also heard of them. I just want to go through them for reference. I think the most famous is certainly word2vec, which is literally words to vectors. That is what it's doing. And also the new family of large language transformer models are also models such as BERT, Roberta, also GPT, the model behind ChatGPT, and some open source alternatives. And when we talk about applications, I think this is a really neat paper that is very insightful more generally, is, for instance, a team of researchers has used these large language representations to try to understand how the different dimensions of social class change over the span of century. So if you look back in the history, we could see that being well off, being highly educated and being an aristocrat were all kind of concepts that were very close in the space. And then as history progresses, our societies develop, these concepts kind of separate from each other because, you can be well off without being aristocratic, and you can be well off without being highly educated. So there are all these elements that we can then trace by building these models from our textual data. And also in our own work, we have used these representations to measure to what extent the way that a certain person talks matches the way that the meaning is kind of constructed in a broader group. So we've done this with online communities to understand kind of how online communities and their language develops over time. And once again, there's a lot of useful implementations. I think really cutting edge things are usually happening in Python. So this is just a list for reference. And I wanted to reflect now on the question of zero-shot learning and just in general, these new models. I think we're all familiar by now with ChatGPT, or you've probably heard of these large language models that have then been wrapped in a really nice chat environment so that you can talk to a model in natural language, and they can very easily generate text for you, rewrite your emails, give you psychological support. Some people have done that. They can also analyze text, so they can do pretty much everything I've just discussed. You can ask them, hey, is this text positive or negative? And they will give you some output. So these tools have been really developing very rapidly. So we've had ChatGPT. There is also Microsoft's Bing. You can also chat with them. There is Google's Bard chatbot, and there is also Claude. So there have been a lot of these tools that have been proliferating, and researchers have also been adapting them very rapidly to do a lot of things. And I think I will reflect on this as well. Very important to keep in mind that we're still trying to understand how good they are at different things. So we just want this to be kind of there. So based on what I've read so far about this, and some people have been very enthusiastic, I have here 2 screenshots of really interesting papers which use these new models, talk to them in natural language and have them do different things. It appears that they can do really all of this. They can identify concepts of interest in text. They can help us with understanding who does what. They can extract topics, and they also themselves have an understanding of how different words relate to each other, although that is a little bit more difficult to extract from them at times. But definitely, they're very useful, and I think definitely it should be kind of tested what they can do for different applications you might have. But now I would like to go over some challenges of using these methods. And I think something to begin with is really on the side of our data, and especially if you're collecting large data sets from online environments. It's a lot of data we're kind of getting, whether it's from social media or maybe from newspaper articles or maybe governmental websites, is collected through either APIs, so through platforms giving us access to the data, or by scraping the websites. That is, we're just going with little programs through the websites and we're downloading their content. Well, this is very powerful because it gives us a tool of collecting data unobtrusively. We don't have to go and survey people and ask them things or have them sit in the lab and do experiments. On the other hand, the fact that these texts are generated not for researchers, but they're just a byproduct of people living their lives or doing their jobs as journalists, these texts can miss important variables that we need as social scientists. And they can be of questionable representativeness. Because if you're downloading data from somewhere like Twitter, which is now also not even possible anymore, or forums such as Reddit, you're never sure who are exactly the people you're capturing by doing so, especially if you work with social media data, because we don't know anything else about these people apart from what they've written online. And there is also often a lack of transparency as to, have we gotten all the data we wanted? Have we gotten all the news articles? Have we missed something? So these are the things that I think are very important to keep in mind. And we need to be mindful of how we collect our data and what can be done with them. There is also a question of analytical choices. This is something I've personally found very difficult when working kind of with data and the models and the methods and the machine learning approaches, is that, as you've seen just now, multiple models can do the same thing. And sometimes it's a question of what's the most applicable one for you. And then also some of these models are very complex, and there are many parameters that you can change and adjust: the speed at which they're learning things, the speed at which they're forgetting things, which features they select. So there's just a lot to take into account. And I think for social scientists, we're used to a certain set of methods. This can be quite overwhelming. We also don't have many decisions of how do we transform our textual data into numerical representations. And this can include different steps, different pre-processing, different choices of these large language models if you want to vectorize your data into these multidimensional spaces, etc. So these are all decisions that I think we just need to develop best practice advice for and be very mindful and transparent about. And then I also want to note that the fact that this field is very rapidly developing, and there is a lot of enthusiasm from many sides about these new tools. And I recommend these really exciting new papers. These are all still preprints, so they haven't even been published in journals because our scientific system is sometimes even a bit too slow for all the developments. Is people, for instance, have used ChatGPT, these large language models wrapped in these chat environments, and show that they're very effective in psychological text analysis. And some colleagues have even said, maybe this is the end of our manual work. Maybe we don't even have to do all that much manual work because these models are very powerful and they're very easy to use. And I think the fact that they're easy to use also obscures the fact that we are not very good at understanding what they do. And not only us as, lay people who are trying to use these methods, but even the people developing them, the mathematics behind these models is still sometimes obscure. So it's just important to know that we're not always sure exactly what's going on under the hood. And then as the time comes, you will see that then some new papers are saying, hey, actually chatbots might not be all that reliable, or automated annotation with these models requires human validation. And both of these sides are right. So the papers I've just shown on the previous slides, and these papers are both correct. The only thing is that they've been using these tools for different tasks. They've been using them on different data sets. And then it just turns out that they're better at doing some things than some other things. So I think it's just very important to keep this in mind, that there is no kind of universal remedy for all of our problems. And it's just the same kind of methodological problems we've always faced. Do you want to use a logistic regression or do you want to use a linear probability model? We just need to be mindful of different applications. And there's another problem that I think arises more and more as these tools developed by companies who then keep them proprietary, who charge you to use them, is that unlike some older models that are all kind of openly available, if you use ChatGPT, you're not exactly sure what these models have been trained on, what are the textual data that they learn from, which might be biased themselves. And you might be feeding a kind of proprietary model, copyrighted material that contains private information of your survey respondents, or texts that are copyrighted. And these models are also still, as much of the text analysis tools, English-centered. So we still miss a lot of resources that are catered towards less kind of researched languages. So it might still be very important to be mindful of the fact that, if you work in a different language than English, these models might be much less powerful when you're trying to do this. I think another important question, although I am running a little bit out of time, but I think it's just important, I want to mention this. This is a kind of traditional problem of text analysis is, can we actually capture any constructs and any coherent meanings from text at all? And if we quantify things that are said in texts, are there some things that we inevitably lose? And can we then even use these measures at all? So I will not go into the kind of philosophical discussions of this. I think this is a very, very inspiring thing to read about. But I think there has been this very, I feel, reasonable and pragmatic approach outlined in a recent book by Grimmer, Roberts, and Stewart, colleagues who focused on political science and text research in it, where they say that it's most likely that there is no single underlying truth in any of the texts we're analyzing. There's no single concept that can be extracted in the best possible way, but it's really about what are the concepts we are interested in different texts, what are the ways that we can approach this, and they give very good advice, I think, about kind of thinking about your measures, making sure they're theoretically informed, but then also in touch with the data that you're actually working with. So this is really a very, very good, I think, resource for these kinds of questions as well. And now we'll just briefly go through some of the opportunities. You will see many of them will reflect the challenges I've just outlined. And I think when it comes to asking ourselves whether our constructs are valid, it's very promising that a lot of research has been now trying to validate measures extracted from text against alternative ways of measurements. So for instance, survey measurements, or even what people actually end up doing, how their attitudes expressed in text relate to what they actually end up doing. And then also if we're thinking about whether our text mining methods are doing what we think they're doing, we've been also doing quite some work in our research on trying to understand how the different methods and the measurement, the things they extract from text relate to the work done by our human coders. So then at least we can compare these models always against a reference we're familiar with. So humans are not perfect at understanding what's going on in text, but then we at least know how different machines compare to this. And I think this view of seeing these text mining tools as just a way to augment our human capabilities rather than some kind of omnipotent machine that can do all of this for us is a very helpful and humbling way to look at it. Something very interesting, I think very promising, because a lot of work using text in sociology and social sciences tends to be very descriptive. There's been a new framework proposed. It's systematic and technically very, very well thought through on using text for causal inference. So text can be used as an outcome in our analysis, and it can also be used as a treatment. And then we can tune the textual measures back into our frameworks for causal inference and in general, just quantitative analysis that we've been doing on top of course, helping us really understand what's going on in our corpora. So I think this paper is also a really nice resource for thinking about text in a causal way. And then I think I will like to maybe close with this. We can also learn a lot from the history of developments of these methods. And this is also very recently posted preprint, which says that the history repeats itself in the era of large language models. And I think maybe I will not read through this because it's quite a bit of a longer passage. But essentially this paper opens, and I really recommend it, with this kind of image of a renowned NLP researcher showing a graph that shows a model that is outperforming anything that we've ever seen at a certain task. So attendees of this conference are visibly shaken, and they realize that things they've been working on for years and years are now just deemed completely obsolete by this new advanced model. And then the authors here in this paper is asking us, does this sound to you like a scene that might have happened in the past year? And I was really thinking, yes, this sounds like these large language models and these new chatbots. But it turns out this exact scene took place in 2005, 18 years ago, when Google introduced their models that they've been using to power Google Translate for machine translation. So essentially what we see also is that these methods, especially the ones for text and different applications, they kind of go in leaps, and every time a new leap is more powerful and more powerful. But over time, we also see that it's just a matter for us also of adapting, understanding their capabilities, understanding their limitations, and just adapting our tools and the way that we do science to these new methods. But they're still just methods in our hands as researchers. And I think I would like to wrap up with this. Thank you very much for your attention. And please let me know about any questions and comments you might have.